Okay, hello. There are still 9 of you, but we'll have to already start the class. So, for today, we are going to talk about one of the drawing systems that we have. But before that, we have to review what these drawing systems are. There are three of them, and we already tackled the first one last meeting, so which is about multi-view drawings. So the projection system used in multi-view drawings is called orthographic projection, and there is where we learn how to generate the top view, the front view, and the side view. And we also had a homework related to that. And today, we're going to talk about paraline drawings. And there are two types of projections used in paraline drawings. One is axonometric, where we generate what we call the isometric drawings, and also dimetric drawings and trimetric drawings. I'm sure a lot of you have probably heard dimetric and trimetric for the first time because it's not as popular as isometric. The other way of projecting is called oblique projection. And there are two types, elevation oblique and plan oblique. Okay, so this oblique projection and axonometric projection will be discussed in this session. The last drawing system is called perspective drawing, which is not covered in our course, AD1111. 1111. So, and I think from the old curriculum, this is in graphics 2 perspective. Um, so let's go directly to paraline drawings. Okay, it says here that paraline drawings communicate the three-dimensional nature of an object or spatial relationship in a single image. So in just one look, you see three sides, you see three information, the length, the width, and then the height. Hence, they're also called single view drawings to distinguish them from the multiple and related views of plans, sections, and elevations. Now, axonometric projection, the difference between orthographic multi-view drawings and an axonometric single view drawing is simply the orientation of the object. So, um, remember last time we talked about the glass box, and then we have an object inside the glass box. But the surface of the object, like the front view surface, is parallel to the the F plane, no, or one side of the glass box. Now, what happens in axonometric drawing is that the object is rotated so that it's the corner which is um, which is facing the glass box, no, or facing the side of the glass box. So when we project, we actually are projecting from the corner, and then everything else recedes, or in terms of perspective, it vanishes to the sides. So that's the only difference, but the rest of the principles remain. And I mentioned earlier that there are three types, isometric, dimetric, and trimetric. Now you might be wondering why there are three dimetric cubes here. So it's because the dimetric can have many variations. Um, in this case, in the leftmost, we have a dimetric making use of 15-degree angle uh, on both sides. The second one makes use of 15-degree on the left and then 30 degrees on the other side. And then the last one makes use of 15 degrees and 60 degrees on the other side. Okay, trimetric, we will talk about them later. So in isometric drawing, um, it's an axonometric projection of a three-dimensional object inclined to the picture plane in such a way that the three principal axes make equal angles with the picture plane and are equally foreshortened. So you can see here that these angles along this axis, the principal axis, are equal. It's 120, 120, and 120 here. So this is basically the main feature of an isometric drawing. But if we project a horizontal line at the bottom, we come up with a 30-degree angle here based on the horizontal. Okay, so when we draw an isometric, we basically use a 30-degree triangle to construct this. Now it says that the measurements are foreshortened. Okay, we mentioned about foreshortened and true length last time. Now this one could be 1 unit, but when drawn in an isometric, it is foreshortened to, I don't know, maybe 2/3 or 3/4. But then if it is foreshortened to that length, everything else is also foreshortened to that length. Therefore, it's just as equal to 1 unit for everything. So meaning to say it doesn't matter. Okay. So the 1 unit here is the 1 unit here, and everywhere else it's 1 unit. So this is an example of how an isometric is made. Now I just remembered that I forgot to put in um, how to make an isometric circle. So maybe I'll just include that in the slides when I post this in Canvas. So to look for the ridge of a roof, for example, so you'll have to project it from the base and then get the height here, and then also project the center line so that you get that apex here, letter G, the point G. Okay, so this is how it's done. So um, the rest are just projected using a 30-degree triangle. So a diametric is a paraline drawing of a diametric projection having all lines parallel to the two of the principal axes drawn to true length at the same time at the same scale, and lines parallel to the third either elongated or foreshortened. Um, so one, it says here that all lines parallel to two of the principal axes. Meaning to say, for example, in this case, let me see. Um, I don't quite understand how they defined it, but in this case, this one, since it is facing the main projection plane, so it's in true length. The rest are foreshortened. But then the thing is, there are there are three types. So in this case, this one makes use of 15 degrees, as stated earlier, and then the um, the dimension now of 1 unit is foreshortened to 3/4. Okay, so let's not bother ourselves with the definition because I have to think through what it really means. No, but uh, I just copied pasted from the book. And then this other side is also foreshortened to 3/4. So this is what happens when you make use of 15 degrees and 15 degrees. And then if you're going to use your triangle to get a 15 degrees, so because we only have either a 45 or 30/60, so we have to combine both triangles to form the 15 degrees. So we have to do it this way, as illustrated. If we use 15 degrees and 30 degrees, so two axes have is shown in true length, and then one of the axes is shown foreshortened. Okay, so the one in 30 degrees. But then if we use a 15 degrees, So only the base is in true length, but then the rest are foreshortened. It becomes 3/4 of 1 unit. Okay, so that's the ruling in making a dimetric drawing. Now, trimetric, we're not going to, this is very seldom used, almost rare. Um, so we're not going to delve so much about it. All we need to know about this is that it is like rotated so that not any no part of it is actually like parallel to any of the projections, or simply it says here that all three principal axes are foreshortened at a different rate. Okay, so you don't have a same scale, like it's this is 3/4 and this is probably 2/3 and that is probably something else. So it's not like the rest where you only have two options, either a full scale or a foreshortened 3/4, no, and you don't have a third scale. Now oblique projections, um, let's see, it says here oblique drawings show the true shape of planes parallel to the picture plane. Okay, and to this frontal view, top and side views are attached and projected back into the depth of the drawing. So in oblique projection, the object is now facing the projection plane. Therefore, the surface, especially the front, is shown in true shape. But then the top and then the side view are inclined, okay, are drawn oblique. Um, so there are many ways of drawing it. As you can see, they can be drawn at 30 degrees, 45, 60, even 75. But then the front, which is shaded here, is always in true shape. Okay, when it's true shape, it's actually making use of true length. This is really the measurement. Okay, now as to what scale to use in the receding lines for the top view and the side view, that depends on the angle used. Okay, um, so what we just discussed is called an elevation oblique because we showed the elevation to be in true shape. Okay, so basically what you do is like you just draw the elevation like this, and then you project it at the sides, no? And then you draw the rest. Of course, in this portion, it has to be moved back, farther backwards because the only thing that remains in the front is, of course, the part which is more attached to the or nearest to the projection plane. So this is another drawing showing elevation oblique. This is very useful. For example, if you have a multi-layered wall, then you wanted to sort of deconstruct the wall to show each layer. So you make an elevation oblique. Example, this layer contains like, or another option is that another application is that, for example, this section or this bay in the wall may have different options for designs. Um, you can have this type of design or this one or this placed there. So you show all the options here in one drawing and then project them like that using elevation oblique uh, drawing. Now, I mentioned that this is in true length, but what happens on the receding line, supposedly receding line along the side and then the top? Now, one way is to use the same true length. So one here means it's 1 unit. If this is 1 unit, this is also 1 unit. And this method is called the Cavalier projection. Okay. Um, so basically, everything is like an isometric. So the actual measurement is also applied to the sides. Okay. Um, Wait. So I made a mistake here. So this is supposed to be cabinet projection. This one, instead of cavalier. So in cabinet projection, the scale used on the sides and the top is foreshortened, not actual, not the true length. Okay, it could be 3/4 as shown earlier, or it could be 2/3. Okay, now this is called cabinet projection because the way to draw cabinets before, and in some cases now also, is like this, no? So the front um, is more important, and then the side they don't have to, they just show a little, um, and then just put the dimension drawing. So this is how carpenters do it. So that was elevation oblique, and then we also have the plan oblique. Okay, in the plan, this time it's the floor plan which is parallel to the plane of projection. Therefore, we are looking at the drawing from the top. Okay, because the floor plan is always horizontal, and then if you want to see it normal on a normal view, then you'll have to fly and then look down. Okay, but then the difference is, if the plan looks like this, we have to rotate it to this position so that what we see is like this. Okay, so this plan is shown in full scale through shape. Okay, but then the rest of the lines are foreshortened. So we can use a 3/4 scale, or you can also use the full scale. Okay, so the actual measurements. Now, this is an example of how a plan oblique is drawn. And then again, there are variations. No, you can use, you can make use of 30 degrees or 45 or 60 degrees. Okay, so as you can see, it's useful to show the plan. Uh, it's like an interior elevation. Let's like an interior section, okay, or a section plan, except that it's not perspective, but making use of paraline drawing. So it tells you a lot of information. So these are the applications. You can use a phantom view. For example, all of these things are inside a box or a warehouse. But then since the warehouse is so simple, and it's better to show what's inside. So you show the outer shell as a phantom line, and then you draw the inside. Okay. Another one is cutaway view. So it's like a section, okay, but in 3D. So here you have the plan, and then you wanted to project the plan but show it as a section. So you do it this way. And then you also have expanded, or sometimes called exploded view. So you cut the plan into pieces, into layers, and then separate them to show what's inside each layer. So in this case, each floor. If you are going to make a furniture, sometimes an exploded view is used to separate the components of the furniture, and so that you can label them, and then you can see what's inside. For example, the table, if you lift the top, what's the carcass, how does it look like? The drawer, for example, how it's constructed. So it's easier to imagine for the client, and even for some of the carpenters. Drawing approaches. Okay. Um, so there are three approaches to drawing, to making a drawing, uh, based on the application that I showed you. One is subtractive approach. You start off with the bulk, the main mass, and then you just cut off some portions which are not necessary. So you cut this off, and then you get your actual shape. Okay, so you subtract. The other one is composition of discrete forms, or basically adding on. You put on the main element, the main mass, and then you just add on the others like this. Then you get your shape, your form. And then the last is starting with the horizontal plane, probably your floor plan, and then you extrude. No, if you know SketchUp, you extrude it, but this is not SketchUp, so you draw, but you extrude. Okay, you project upwards, and then there is also an alphabet of lines when we draw in paraline projection. Um, there should be a hierarchy of lines. Now, in this case, there are three possible layers or possible application. Spatial edges are the boundaries of a form separated from their background by some intervening space. So all the number ones here, for example, this. So they are completely far from the surface. Therefore, you have to make this thick. Okay. So to define that they are far. In this case, this is the main outline of the object, so you have to make it thick. Okay. This one also, to emphasize that there's a hole here, so you have to make this thick. This one. And then you have number two. Planar corners are the intersections of two or more planes that are visible to the eye. So they are adjacent, but there's a corner like this. Number two. Okay. So therefore, this is medium line weight. So these are just corner, medium line weight. Okay, this is a corner, so medium line weight. And then the last is surface line, which are lines that represent an abrupt contrast in color, tonal value, or material. They do not represent a change in form. So it's on the same plane, but there has to be some division, possibly because there will be a change in terms of materials or texture. So they can be the lightest line. No? For example, here is, I think there's only one, number three. Okay, so you have to follow that convention. Now, sometimes, even if you follow that, the drawing is still not very, um, it's still difficult to appreciate the drawing, especially the massing. So, another strategy that is used is to darken. How does it say here? The most important distinction to establish is the orthogonal relationship between horizontal and vertical planes. So here you can't appreciate yet the vertical planes compared to the horizontal. But then if you shade the horizontal, at least the floor, the base, um, you get more appreciation of the whole mass. Okay, and normally what is shaded is just the base, or the floor, no? The floor. So not all the horizontal. Very good. I think that's the last slide. So your homework, actually, it's a lot of drawing because you're going to draw this. So pardon the little drawing in the top. Um, you're going to draw this like 5 times. One in isometric, making use of 30-30, 30 degrees, 30 degrees, and then twice in the metric, one using 15 degrees and 15 degrees, and the other one using the 15-60 combination. Okay, and then the last one is as elevation oblique. Um, you draw it twice, one using the Cavalier method, the other one the cabinet projection method. Okay, so that will be your homework. So it's one drawing per piece of paper. So I will publish it later, but because I still have to figure out the scale. and also I have to draw all of this in AutoCAD to make sure that they fit. Otherwise, I'll be barraged with so many questions. No? So it's what's going to happen is something like this. So this is not the actual object. This is an example. So isometric, dimetric, two dimetrics, and then two um, elevation obliques. Now we there will be no classes next week. It's the USC days. So we are encouraged by the administration not to hold synchronous classes like what we're doing now. So therefore, this assignment is good for 1 week. Okay, I will make the deadline Saturday next week. That will be 24th. No, the 31st. So you have a lot of time to draw and experiment, and make sure that you apply the hierarchy of lines, the alphabet of lines, okay? And if necessary, to also um, emphasize the horizontal plane. Okay, that's it for this session. Um, there are only 24 of you. Um, are there any questions before we end the session? None. Anyway, so this is recorded, and you can always refer to the recording. I'm also going to upload the slides separately because, as promised, I